Hello guys, let's solve another Leetcode problem, reorder list. We are solving blind 75 Leetcode questions, and we are in the last question of linked list section, and we are solving this reorder list. This is a medium difficulty problem. So we are given a linked list, and there is a numbering system also in the linked list. So the first node is represented by L0, then L1, and the last one is Ln, right? So we'll assume the L0 is the start pointer and the N is the end pointer for this list. We want to reorder the list in the following form. If L0 is the start, Ln is the end pointer, we want to make it L0 and L1. So basically L0 will point to the Ln, right? And then same as like recursively do the next part, right? So let's try to draw it so that it make more sense for the first problem, right? So 1, 2, so 1, 2, 3, 4, right? So if this is our L0, which is start pointer, and this is Ln, right? So basically what we want to do, this is the remaining portion of the linked list except that L0 and Ln. What we want to do, we want to reorder the list in a way so that L0 actually point to the Ln. And Ln will point to whatever result we are getting from here, 2, 3. Same thing for the same second example. So 1, 2, 3, 4, 5. So 1 will point to 5. So 1 is point to 5. And then you basically 2, 3, 4, you want to call the recursive function and whatever the result you want to point to 2, 4, 3. If we can use recursive algorithm, it's easy to implement, but so there are some AS cases which you need to be really, really careful. If you do it in Python, so the command they said do not return anything, modify head in place instead. So we want to update the head, that we don't want to actually return anything from this reorder list function. And if you want to use some recursive function, so we will write our own function. So what are the thing do you need, right? So at first the S case, if your head is none or head.next is none, you basically want to return because you don't need to do anything because it's a null node or one node, you don't need to do anything. The only time you need to update this list, you have more than 2 nodes, right? So then for this each node, there is no indexing system. So we'll create an index. So we'll create an index with K0. And we want to actually store this in a dictionary, right? So we will have a node dictionary where we will store this index to this node list node. And our current is head. And then if you want to just store it into a dictionary, you can go to while current and node dictionary. You just update node dictionary K with this current node. You can update your current node to current.next. And then basically you want to update the K plus 1, right? So what will happen after these steps, all these steps, you will have all the nodes that 1, 2, 3, 4, 5, the L0, zero number will be indexed, right? So 0 will point to the first node, 1 will point to the second node, 2 will point to the third node like this. And finally, we want to call a recursive function, which will return our head. And we'll write the recursive function recurse, right? So just go with recurse. And then what are the things you want to pass on? You want to pass on the index, start index. You want to pass on the last index and also the node dictionary. And that's pretty much it, right? So now let's talk about actually how we can write the recurse function, right? So to write the recurse function, so we'll define the recurse function. It will take a start location. It will take a end location. End is actually the index. So start index and end index. It will also take another dictionary variable. And that's pretty much it. So for these one, what we want to do. So if your start index is more than, if your start index is more than your end index, you just want to return none. If your start and end are equal, so what do you want to do? So S and E point to the same node. So you at first get that value, get that node from your dictionary. And then you want to update your next pointer to none and basically return that in node, right? So what we did, if your S and E, so for example, 3, if for the case of 3, if your S and E point to the same location, so for the 3, you can see at the right side, 3 is pointing to the next, 3 next is none, right? So basically for one node, you just update the next to none and return that node. Okay, so if these are the two test cases, right, S is greater than E or S equal to E, we'll do this one. Otherwise, that means the other cases, that means E is more than S, right? So now we can take two values. You can actually get the S and also the N2. So you got this two pointer, two node from these two different index. So in this case, there are two things might happen, right? So what will happen actually if you have only two nodes, right? So for example, if you have only 2 and 3, so if you look about this 2 and 3, what will happen if you take a look at this picture? So for 2 and 3, if you have only two node, so you want to, so this is your N1, so 2 is your N1, and this is your N2, right? So what you basically want to do if your S plus 1 equal to E, then your N2 next, so these 2 and 3 will come to here, right? So this is 2 and 3, and 3 will point to the none pointer, right? So in that case, if this is the case, you basically want to do N2 dot next equal to none. And you want to return just N1, because if you have only 2, 3, you just update the pointer of the 3 to a none, and then you basically return the whole thing. And now let's talk about the other part. So where it's more than S plus 1, E is more than 1, S plus 1, which is the case of example 2, right? So in the example 2, you have 1, 2, 3, 4, and 5, right? And basically this is the remaining part, right? And this is your S is 1 here, 0, 1, 2, 3, right? So this is your 3, right? So if that is the case, what you want to do, right? So what you want to do, At first, you can increase your s pointer, s value, s plus equal 1. You can decrease your e to 1. And then you want to update your next pointer n2.next with the recursive call, right? So self dot recurse. You basically call this SE and not dictionary. And you want to return N1. Yep, that's all. So let's talk about what happened here. So your S was at first these one, right? So 0 and E was here 4. You got the 2 node. So this is your N1 and N2. This is your N1, this is your N2. And what you want to do, so your that 1 and 5 will come to the beginning. And for the 5, n2.next would be whatever you return from here, right? So n2.next would be you are calling the recursive function with updating s and e. So basically you are giving s equal to 1 and e equal to 3. So whatever the recursive function will return, right? And basically you want to return these heads. So 1, not to return. Yeah, that's all. So let's see if there is anything wrong with the code. So we see actually there's something wrong. So 1, 4, 2, 3. So that means there is a bug here, right? So let's look at the part where we missed something. So our output is 1, 2, 3, but we missed a 4, right? So basically, let's see what did we miss. So let's go through line by line. So your K is 0. No, dictionary is a dictionary. And then while we have current, we are updating node K with the current and then current equal to current dot next and K plus, right? And here we're calling this recursive function 0K minus 1. So this looks good to me. Let's look into the recursive function here, right? So in the recursive function, we have s plus greater than 1, we are returning none. If s and e are equal, we are getting the value from the node dictionary s. And we are updating n dot next equal to none, and then we are returning n. So now we are getting n from the node dictionary s and also e. And if your s plus 1 equal e, then we want to update the n2 dot next equal to none, and we want to return n1. So we are going s plus 1 equal to 1, e minus 1, n2 next equal to, so basically 5 next would be this one. And we missed one thing. So here it seems like 1 needs to point to this 5 as well. So n1 dot next needs to be point to n2 before even returning n1, right? So L0 will point to, so we missed this part here. Let's run it. Okay, I think it looks good. Let's submit it and talk about the runtime complexity and space complexity. Okay, that looks good. So let's talk about runtime complexity and space complexity. So we have a recursive function. So, and for the extra variable, we're using node dictionary, which can store order of n. So basically, if you have n nodes, you are using order n space, right? So this is for this using dictionary. We are calling recursive function. And for each of the recursive function, for each of the pair of nodes, you are calling only once. So it will be bound by order of n. So overall, the runtime complexity would be order of n, and the space complexity of also order of n, right? So this is the algorithm we can come up with order n runtime and order n space. Yeah, that's pretty much it for this problem. Thanks for watching, and we are done with the linked list problem to blind 75. So we will go into the next section for this video playlist. Thanks for watching.